Hello and welcome to Algebra 1 by eMath Instruction. My name is Kirk Weiler and today we're starting a brand new course here. Algebra 1, Unit 1, Lesson 1 on variables and expressions. And I'm excited to start this course with you, right? We've got a long road ahead of us, but by the end of it all, you'll be much better at algebra than you were in middle school, and hopefully you'll have the building blocks for success in future math courses. So without further ado, let's launch right into our lesson on variables and expressions. All right, so first, let's talk about what an expression is. An expression is any combination of numbers and/or variables and using addition, multiplication, subtraction, and/or other operations such as exponents, right? So, and this is important. In math, you've got numbers that just kind of hang out, right? But then you've got expressions, specifically numbers and variables that are combined with addition, subtraction, multiplication, division, roots, exponents, etc., right? So let's jump right in and look at just some numerical expressions and how to evaluate them. Let's take a look at exercise number 1. Review the order of operations by giving the value of each of the following purely numerical expressions. Do these without a calculator in order to review basic middle school number concepts. All right, awesome. So let me just bring this up to the top of the sheet so we've got a little bit more room to work with. Now, keep in mind, order of operations are our rules for the order in which we are supposed to evaluate or interpret algebraic expressions. So let's take a look at letter A. Right? In letter A, we have the expression 3 times 2 plus 7. And in this case, we're showing the multiplication with the little dot symbol. Now, our order of operations tells us that multiplication must come before addition. So in other words, I want to think about this and evaluate it by saying, well, the first thing I'm going to do is do 3 times 2, which is just 6. And then I'm going to evaluate 6 plus 7, and I'm going to get 13, right? And that is exceptionally important because if we look at this and interpret it as, well, I'm going to add the 2 and the 7 first, which would give me 9, and then multiply by 3, which would give me 27, I'm going to get an entirely different numerical result. That's where this order of operations is so key. We have to know how to do it. All right, so what I'd like you to do right now is I'd like you to pause the video and I'd like you to just attempt letter B and letter C. See if you can remember your order of operations and how to do those, and then we'll move on and together we'll take a look at this second row of problems that are a little bit more challenging. All right, now again, generally speaking, when we read an expression, we want to read it from left to right. So in letter B, we have 8 minus 1/2 times 6 plus 24 divided by 6. Now again, order of operations tells us that we should be doing the multiplication and the division first. Which one of them should we do first? Well, multiplication and division tie with one another. And so when you have a tie in order of operations, you really kind of do it just from left to right. So what I'm going to be doing is I'm going to be figuring out what 1/2 times 6 is and what 24 divided by 6 is, and I'm going to be putting those into the expression. Now, keep in mind, right, that 1/2 times 6 is the same as 6 divided by 2, so that's 3. 24 divided by 6 is equal to 4. And now that I have only subtraction and addition, I really do it from left to right. So I have 8 minus 3, which is 5, plus 4, and 5 plus 4 gives me a final numerical result of 9. All right. Order of operations also tells us that when we have quantities within parentheses, those quantities should be evaluated first before we do anything else. So in letter C, we have 4 times 8 minus 6 minus 7 times 5 minus 3. So the first thing I'm going to do is those very easy differences in the parentheses, right? And I'm going to get 4 times 8 minus 6, which is 2, minus 7 times 5 minus 3, which is also 2. Now I'm going to do the 2 multiplications. So 4 times 2 is 8. 7 times 2 is 14. And here's where you want to be very careful, right? Whenever I have a smaller number minus a larger number, I get a negative. And specifically in this case, I get -6, right? So we do those operations that are within the parentheses first, and then we proceed afterwards. Now let's take a look at some more challenging problems in D, E, and F. All right, so looking at letter D, we finally have some exponents involved, right? I've got 5 to the second, 4 to the second, plus 3. I've got a fraction involved. Whenever I have a fraction involved, we really want to look at the numerator, the top, and the denominator, the bottom, as if they have parentheses around them, right? I want to evaluate that entire numerator, that entire denominator, and then do the division or do the simplification of the fraction that's sitting there. So, when I look at this numerator and I see 5 to the second minus 4 to the second plus 3, I want to do those exponents first. All right? So I get 5 to the second, that's 5 times 5, minus 4 to the second, that's 4 times 4, and plus 3. And I can evaluate the denominator. 1 minus 5 is negative 4. Now I can evaluate that numerator going from left to right. 25 minus 16 is 9, right? So I have 9 plus 3. 9 plus 3 is 12. And now I have 12 divided by negative 4. Keep in mind that when you have a positive divided by a negative, you get a negative. And so I have a final evaluation of negative 3. All right? Exponents come before multiplication and division. They come after parentheses, though. So if you had parentheses, those would take precedent. Take a look at letter C. Here we finally have a square root involved. We have 22 minus the square root of 36 plus 64. And just like numerators of fractions, we want to kind of think about there being parentheses within this quantity under the square root. So we want to do that addition first. Then we want to find the square root. And after we do that, we want to do the subtraction. Pause the video now and see if you can work on both letter E and letter F. Try to get final answers, and then we'll go through both of them. Take a couple minutes. All right, let's do it. As I said, in letter E, the first thing I want to do is I want to add the 36 and the 64, right? So when I do that, 36 plus 64 is 100, right? Now I want to think about what the square root of 100 is. Remember, the square root is the number you have to multiply by itself to get the number under the square root. So that's going to be 10, right? The square root of 100, 10 times 10. Let me do this. And of course, 22 minus 10 is just 12. That's easy enough. All right, now let's look at one that looks absolutely horrible, right? Because I've got negative 16 divided by 2 plus 5 times 2, all divided by 2 to the third. Another exponent going on there. There's a lot of different things I can do. Keep in mind, of course, the numerator and the denominator are completely separate from each other. I really only want to have those two interact, kind of like what I did in letter D, once I've simplified everything. So let's jump right into this problem. All right, in the numerator, I can do that division and multiplication. Negative 16 divided by 2 is going to be negative 8. 5 times 2 is 10. Now I can do the exponent, the denominator. 2 to the third, remember, is 2 times 2 times 2, and that's equal to 8. Right, I can now simplify the numerator. Negative 8 plus 10 is a positive 2. And 2/8, of course, I can simplify this fraction by dividing the numerator and denominator by 2. And I find the final answer there is 1/4. All right, so we're just working through orders of operations. Remember, parentheses, exponents, multiplication and division tie, and then addition and subtraction, and they also tie. And you kind of break the tie by just moving from left to right. Now, all of these expressions were completely numerical. Let's get into some that involve some variables. All right. So once an expression involves a variable, it's important to be able to read the expression, be able to look at it and sort of understand what's being done to the variable without having to like plug a number in. So let's get a little bit of practice on that with exercise number 2. If the letter X represents some unknown quantity, explain the calculations/operations that each of the following expressions represent. State both the operations and the order in which they occur. All right, so in other words, when I look at this expression, 3x minus 8, that's the way I would read it, I want to immediately know what's happening to x. Now, again, I do this by thinking about my order of operations, right? If I took a value of x and I actually replaced the variable with that value of x, the question would be, well, what would happen, right? Well, order of operations says the first thing I'm going to do is the multiplication. Remember that 3 just sitting beside the x means that we're doing 3 times x. So the first thing, right, is we're multiplying by 3, right? That's the first thing. And then we're taking the result. That looks beautiful. Taking the result and subtracting 8. My handwriting's going to eventually get better. I just kind of a little out of practice now that we're in a new course, right? But I want to be able to look at this and immediately know, oh, what that expression is doing is taking that value of x, whatever it is, we don't know at this point, multiplying it by 3, and then taking that result and subtracting 8 from it. What I am most certainly not doing is taking x, subtracting 8 from it, and then multiplying that result by 3. All right? So see if you can pause the video now and write down what's happening in both letter B and letter C to that variable x. All right, well, letter B is fairly simple. Letter C is a little bit more complex, right? In letter B, right, what I've got, the first thing that's happening is I'm subtracting 4 from x. The second thing I'm doing is I'm taking the result and I'm dividing it by 2. Remember, fractions are division. You're always taking the numerator and you're dividing it by the denominator. So in letter B, give myself a little bit of room, first thing that we're doing is we're subtracting 4, and the second thing is we're dividing by 2. My mystery red pen finally made an appearance, right? Now letter C, again, it's important when we look at 4 times x squared minus 8, right? We have to know that the first thing that's happening is we're squaring that x, right? We're multiplying it by itself. Then we're doing the multiplication by 4, and then we're subtracting 8, right? So these 3 different steps. The first one being we are squaring x, then we're multiplying by 4, and then we are subtracting 8. And it's critical because so much of algebra involves expressions that have variables in them. If you are reading them incorrectly, if you're thinking about the order that they're done in the incorrect order, then it's going to be chaos, right? It's just going to be pure chaos. All right, let's keep going. Now, of course, what we want to be able to do is sort of a combination of what we did in exercise 1 and what we did in exercise 2, which is evaluating expressions. Now, what does it mean to evaluate expression, right? It's finding the value of an expression containing one or more variables when the values of those variables are known, right? So we have to actually know what the value of the variable is. But once we do, we have to feel confident with our order of operations and just our ability with numbers and stuff to be able to actually come up with the value of an algebraic expression if we know what the variables are equal to. So let's take a look at some of that in exercise number 3. Find the value of each expression given. Show the steps you use to find your final answer. Only use your calculator if necessary to check your final results. Simplify any fractional answers. All right, great. This truly is a combination of what we did in exercise 1 and what we did in exercise 2, right? So if I look at letter A, I've got the expression 4x minus 7 when x is equal to 5. In other words, I want to know what 4x minus 7 is when x is 5. So the first thing I have to know that what's going on here is I'm taking x, I'm multiplying it by 4, and then I'm subtracting 7. Now I want to substitute in the value of the variable. So what does that look like, right? So I want to be careful. I like to show multiplication by using a parentheses, right? So I've got 4 times 5 minus 7. I now do 4 times 5, which is 20, minus 7, and 20 minus 7 is 13. So the expression 4x minus 7 has lots of different values depending on the value of x. But when x is equal to 5, that particular expression is equal to 13. All right? Let's do another one of them together and then have you do some of the more challenging ones on your own. And then we'll go through them. Right? So in letter B, we've got 25 minus 2/3 times n. And again, keeping in mind what we're really doing is we're taking the value of n, which in this case is going to be 12, we're multiplying it by 2/3, and then we're subtracting that result from 25. So let's take a look after we do that substitution, right? 25 minus 2/3 times 12. Now keep in mind, whenever you multiply by a fraction, you're really doing a division problem. 3 goes into 12 4 times, and then you're doing a multiplication problem. 2 times 4 is 8, right? And now, of course, 25 minus 8 is 17. You can, of course, use your calculators to do many of these things, but we try to keep the numbers purposely small and relatively easy to work with early on in this course because we want you to build up numerical fluency without the calculator. So try as many of these as possible without using your calculator, but certainly if the numerical work is getting in your way, grab that calculator. That's what it's there for. All right, let's take a look at some that are a little bit more challenging. All right, now keep in mind, right, order of operations, parentheses, exponents, multiplication and division, tie, and then addition, subtraction, tie. And that's important because here we've got some exponents going on in letter C. All right, let's do letter C together and then we'll have you do letter D on your own. So letter C, we've got c squared, c to the second, plus 6 times c for when c is equal to -4. Now, I want to be good about my substitution work here. Because I've got a negative number going on, all right, it's great to put that negative number in parentheses. So I have -4 squared plus 6 times -4. Keep in mind that -4 squared, -4 times -4 is positive 16. Then a positive 6 times a -4 is going to be -24. All right, so I now have positive 16 plus -24 is going to leave me with an overall -8. All right, again, easy enough if you know your order of operations and you know some basic facts about negative and positive numbers. Why don't you go ahead and try letter D. Pause the video now and take a few minutes to try that one. All right, let's go through it. So in letter D, we have 1/2 times t squared minus 2 times t plus 9 for t equals 6. Again, let's be careful, right? When I do the substitution, I'll almost always put whatever value I'm substituting into parentheses. All right. Order of operations tells me I should do that 6 squared first. 6 times 6 is 36. Maybe we'll leave all the other multiplication alone for right now. Now, 1/2 times 36. Remember, that's just 36 divided by 2, so that's 18. 2 times 6 is 12, plus 9. Now I'm just going to add from left to right. 18 minus 12 is 6. 6 plus 9 is 15. All right, great. I hope you got that one right. We've got one more row to go on these evaluations, so let's take a look at letter E and letter F. All right, letter E, we've got the square root of 5x minus 4. And again, keep in mind, things like square roots and denominators of fractions, you can really think of these as having parentheses around them, right? They're just sort of like naturally grouped. So I want to figure out what that 5x minus 4 is when x is equal to 8, and then I want to take the square root of it. So pause the video now and see if you can actually do both letter E and letter F. See what you can do on those. All right, let's do it. So letter E, right? First thing I'm going to do is put the square root, make it nice and big, 5 times 8 minus 4. I am literally going to just ignore the square root symbol until I have a single number underneath it. 5 times 8 is 40 minus 4. Still ignoring the square root. 40 minus 4 is 36. And finally I can say, all right, what is the square root of 36? Well, that's 6, right? Because 6 times 6 is 36. All right, but keep in mind, right, I didn't even bring that square root in until the absolute last moment. It's very similar to the fraction, right? Here I've got 6 divided by y cubed plus 4 for y is equal to 2. So, first things first, I'm going to put the 2 in, cube it, plus 4. Right? I'm going to ignore that numerator, nothing I can do with that. I'm going to do 2 to the third, 2 times 2 times 2 is 8, plus 4. Now I'm going to sum in the denominator, 8 plus 4 is 12, and I can divide both numerator and denominator by 6, and I find that my final result there is 1/2. All right, just working it down, right? Working it down, using your order of operations. All right, let's do a little bit more. One more problem. Here we go. Exercise number 4. The amount of money in dollars a tour company earns on a tour can be calculated using the expression 12 times parentheses n minus 4, where n is the number of people who go on the tour. How much money do they make when 14 people go on the tour? All right, so there's a lot of words here that you got to kind of work through, but everything that you need to figure out the answer to this problem is sitting right in there. Pause the video now and see if you can figure out how much money the tour company makes when 14 people go on tour. All right, well, we are told that this expression, 12 times n minus 4, let me just circle it, right, is going to calculate what we want to know, how much money they made by going on the tour company, by taking this tour, right? And the n actually represents something now. N is the number of people who go on tour. So how much money do they make when 14 people go on tour? Well, what that tells us is it tells us that n is equal to 14, and the amount of money that they're going to make is going to be 12 times 14 minus 4, right? Order of operations tells us that we've got to do what's in parentheses first. 14 minus 4 is 10, and now 12 times 10 is 120. So they must make $120 when 14 people go on tour, right? That's easy. It's simple to do something like that. But it goes to illustrate a point, which is very often in real world problems, right? The variables stand for something. In this particular problem, n stood for the number of people that went on tour. And the expression itself, the 12 times n minus 4, right? That represented how much money we would make given that a certain number of people went on tour. So we could use that expression to figure out what we were looking for. All right, let's wrap this up. All right, so today we got into some real basics, stuff that you probably almost rolled your eyes at because especially the numerical work you were probably doing since you were in middle school, right? Maybe even as early as like 6th or 7th grade, right? Even the variable work you certainly have had exposure to in previous courses. But it's important because variables and algebraic expressions, in other words, expressions that involve variables, are going to become the basis of so much of what we do. And so much of what we do is going to boil down to, can you look at an expression, understand what is going on to the variable or variables in the expression? Can you evaluate the expression if you know values of the variables, right? And all of that's going to become important, especially when we then start to undo what's been done to the variables in order to solve equations. All right, but more on that in future lessons. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.